All right, today we're going to take a look at writing functions, domain and range, x and y's in function notation. So function notation is just another way of naming a linear function, which is all that we've been talking about so far. For example, we've had this function form equation before, y equals 2x plus 1. If we're writing it fancy in function notation, we just replace the y with this. It says function of x. F of x is another way to say it. And you want to think of it just as, hey, this is a linear function and the input is x. The output is over here. This is your output. F of x represents the entire output. X is your input. Most of the time you'll see the function notation labeled with the letter F, but sometimes you'll see G, maybe even H. Everything works the same way as function notation, as y equals. The domain and the range is the same. We graph it the same way. Let's see what we can come up with. It says find an output given an input. Find an output given an input. So on our notes, we have f of x equals 3x minus 15. If you don't like seeing f of x, just cross it off and make it a y. But know that when you have f of 3, 3 is the number that you're putting into your function. So if I go ahead, I'm going to erase what I scribbled out there. I might write it this way. My function, when I plug in 3, is equal to 3, hey, plug in the 3, minus 15. And then I simplify. F of 3 will stay the same. That's my function. When I plugged in 3, I get, let's see, 9 minus 15 is negative 6. So my input here was 3. That's my input. And my output was negative 6. If you see this, f of 3 equals negative 6, think of it as input-output. It's the same as the ordered pair 3, negative 6. Let's take a look at another example. Find f of 10. So this is the input. Plug in 10 for your equation, and we're using the same equation as we have up here. So when I have my function and I plug 10 in, it looks like this. See, we're plugging in 10, and then we just go ahead and simplify. There's nothing to simplify on the left side here. That's just telling me that I have a function and we plugged 10 in. And then we go ahead and simplify the right. So 3 times 10 is 30, minus 15. When I plugged 10 into my equation, out came 15. Input, output. And we can write it as 10, 15. An x and a y. So there we just found the output when they told us what the input was. So go ahead and pause for a moment and see if you can find your outputs given the inputs. So we have all of our examples worked out for us here. When we plug in 7 and calculate, we get negative 49. And I chose to complete my problem, but then I rewrote it as an ordered pair just so I could see the input and the output. That's not necessary, but just kind of to help solidify why the input is negative 2 and the output is negative 23 for the second example. On letter C, we plugged in 0 for the x. We got negative 2 as our output. And for letter D, we plugged in 2, we worked with the fraction, and we got 2 as an output. You can also do the opposite. You might be asked to find the input if you're given an output. So here they tell us right in there, find the input. Okay, that means I don't know what the x is, but I know what the y is. So let's keep in mind, anytime I see f of x or g of x, that's a fancy way to say y. So over here, it says find the value of x so that f of x equals 6. Remember, this is a fancy way to say y. So all we're doing is replacing f of x with 6. So 6 is equal to this over here, 2x minus 10. And then we solve. I'm going to add 10 to both sides, and then divide by 2. I'll get an input of 8. So I know what the x is. That was my input. And in the question, it reminds me what I'm looking for. It says find the value of x. So that means you don't know what x is. Think of it as an ordered pair. You don't know what x is until you solved for it. Here we solved for it. So that's the input. But what was the y value, or what was the output? The output was right here. It was 6. So just a different way to look at it, but make sure you're reading the question carefully. It says find x. Okay, then I don't know what x is, but do I know what y is? Yeah, because this is a fancy way to say y. So y is 0. Okay, so I'm going to make y 0, and I'm going to find x if my y is 0. So I add 10 to both sides and divide by 2, and I get my x to be 5. Now I've found x. My x was 5. But what was the y value? If you remember, it's up here in the question. My y was 0. So always read that question. It's going to tell you what to look for, or what numbers go where, if it gets confusing. The other thing that we can take a look at is a zero of a function. A zero of a function is anywhere that your graph is going to cross the x-axis. So it's really an x-intercept. And in our last lesson, we created a table of values to find x and y intercepts. But if you remember, an x-intercept always has a 0 here for y and a value in x. And then this is the case. That ordered pair would be 2, 0. So we have an x and a y. So we're going to take a look at what that means in function notation. You might also have something else, like you might have a curve. And again, anywhere that it touches the x-axis. Algebraically, how do we figure out an x-intercept? We always make the y value 0. So we're going to take a look at that too. So here it says find x given f of x. Find x. Find x such that f of x is 24. Remember, if you want to, make f of x y. So they're telling you that y is 24, but what's x? Go ahead and solve your equation. We get an x to be 5. So if I were to write it as an ordered pair, it would be 5, 24. Or f of 24, oh, nope, I'm sorry. Let me re-erase that. F of 5 equals 24. This is always your x, that's always your y. All right, letter F, it says find x. All right, so I must not know what x is. It's right here, but f of x is 7. Remember, f of x is a fancy way to say y. I'm sorry, 17. So I'm going to place 17 in for f of x, or y, and solve for x. Oops, I did it wrong. I added 3 to both sides instead of subtracting 3. My x is going to equal 2. So in this case, if I want to write it in function notation, my function, when I plug 2 in, is equal to 17. And again, that's an ordered pair, 2, 17. Now G and H ask it, my question a little bit different. It says find the 0 of the function. A 0 of the function is going to be an x-intercept. So if you give yourself a little sketch, it's an x-intercept. It's along the x-axis. So if this was my graph, my x-intercept would be at 2, 0. That means the y value is 0, and that goes for any function. A 0 of the function is when y is 0. So if I take a look at that, that means f of x is equal to 0. F of x is my y value. So I'm going to say 0 equals 4x minus 8. Solve my equation. I'll get an x to be 2. So when I found the 0 of the function, f of 2 is equal to 0. That's the ordered pair, 2, 0. We'll take a look at our last one. Again, it says find the 0 of the function. That means that this part here should be 0. So I'm going to go ahead and solve my equation. X equals 6. So in function notation, I have, oops, I shouldn't say f, I should say g, because this is the function g of x. So I'm going to say g, plug in 6, out comes 18. That's my ordered pair, 6, 18. And that is how you work with function notation. You always want to look for the input and the output. Remember that function notation is just a fancy way to say y equals.